So now that we know how to look for factors, and given factors we know how to come up with a polynomial, here's the star of the chapter. Rational zero theorem. It says if you are given a polynomial with leading coefficient a sub n and constant coefficient a sub 0. If this is a polynomial with integer coefficients, all of these are integers, and this and all of these are bigger than or equal to 0, integers, then the possible zeros are the factors of the constant divided by the factors of the leading term. So in this book, they kind of gear you what to do, and I'm going to go over that with you too. They say this is how you work, determine whether a candidate is a 0, list them out, find the remainder, substitute Cn, since this is the remainder. If the remainder is 0, that means x minus that value is a factor. And let me demonstrate. 25 through 32, it says, use the rational zero theorem to make a list of possible rational zeros, then use the list to find all rational zeros. Basically, they're saying factor this. Well, let's see. The leading coefficient is 5. The constant is a 3. So, it's going to be factors of 3, that's 1 and 3, divided by factors of 5, 1 and 5. So the possible, out of this, what we get, the possible rational zeros are 1 divided by 1, 3 divided by 1, 1 divided by 5, and 3 divided by 5. And of course, plus or minus. Now, one way of figuring out if 1 works, 1 is the easiest number to work with. If I plug 1 in, if I figure out what f of 1 is, well, that is 5 minus 9 minus 17 minus 3. And I notice that doesn't equal 0, so 1 didn't. How about negative 1? Negative 1, that makes that a negative 5, a negative 1 minus 9, a negative 1 plus 17 minus 3. What would that be? That would be 9, 14. 17 minus 17 is 0. Guess what? I just figured out that negative 1 is a 0. So can't I use syntactic division and factor this completely? Can't I say, well, let's go 5 and negative 9, negative 17, and negative 3, and I already know the remainder is 0. Drop the first number, negative 5, negative 14, negative times negative is a positive 14, that's a negative 3, negative 5 times negative 3 is a 3, and that adds up to 0. What does that mean? That means so far I have x plus 1. Now, that means what's left is really 5x squared minus 14x minus 3. And if I factor that, doesn't that factor into 5x and an x, a minus 3 and a plus 1? So there it is. It says, use the rational zero theorem to make a list. The list is right here. Then it says, then use the list to find all the zeros. The zeros are, I'm going to do better than that. Since you're going to be asked to graph this, I'm going to graph it as well. If I want to graph f of x equal, what are the zeros? Negative 1, 3, and negative 1/5. What's the y-intercept? Negative 3. This behaves like 5x cubed. X cubed. And isn't the multiplicity on those a 1 each? I'm going to cross like a straight line. Straight line, there's the graph. I'm going to shrink that graph a bit so I could fit two problems side by side. And there it is. How do you like that? So how often are we going to graph? All the time. We're going to graph non-stop. How about number 28? 28, if I take the constant, that's a sub 0, that's 75. The factors of 75 are 1 times 75. 3 works. 3 and 25. 5 works. 5 and 15. 5, 6, no, 7, 8, 9, no, 10, 11, nope, that's it. And the leading term is a 3. So the factors of 3 are 1 and 3. So take all of these divided by 1. That gives you the possible zeros. The possible zeros. You know what? I'm going to change the format of this. Give me 1 sec. There, I rearranged the problems a bit again. So I spread out number 26. Let me spread out this problem as well. This way, no need to squish things. We have plenty of space. So possible zeros would be what? All the factors, all the purple divided by 1. That's 1, 3, 5, 15, 25, and 75. And all of these factors divided by 3. Wouldn't that make it 1 over 3? 3 over 3 is already there. 5 over 3. 15 over 3 is 5. It's right there. 25 over 3. And 75 over 3 is 25. So those are plus or minus the possible rational zeros. Now the good news. 85% of the time the first two integers work, and 95% of the time the first three integers will work. So you might be thinking that's a lot of numbers. 85% of the time the first two integers on the list work, 95% of the time the third. Otherwise you have to start trying fractions. I'll say more like 98%. Well, let's see. Does 1 work? If I plug 1 in, would I get a 0? F of 1 is, let me do that work right here. Oh, come on. So next stage, f of 1, that is 3 minus 11 minus 35 plus, well, we know there's no way you could add anything to 75 plus or minus and make it a 0. So 1 doesn't work, for sure, because that doesn't equal 0. How about negative 1? That's not going to work either. That's a negative 3 minus 11 plus 35 plus 75. Again, the 75 is too high to break. How about 3? Now, you could plug in 3, or I would rather try this. I would rather throw a 3 in and do syntactic division. I think it's easier. That's only me. It's up to you. Throw the 3 down. 3 times 3 is a 9. Add. 3 times 2 is negative 6. Negative 41. And that will give me 100. That didn't work. Okay? Automatically, no need to redo the problem right there. Try negative 3. Does that work? 3 times negative 3 is negative 9. That's negative 20. Negative 3 times negative 20 is 60. 60 minus 35 is 25. And negative 3 times 25 is negative 75. And what do you know? I got it. So far I have f of x equaling x plus 3. Now I have 3x squared minus 20x plus 25. And we know the drill. We need to factor that. 3x and an x, a 5 and a 5, and there it is. Meaning 3 and 1, 5 and 5, add up to get me 20. 15 plus 5. So how do you factor? It's up to you. And three x minus 5 into x minus 5. And I am going to ask you to graph. So let's graph it. So to answer the problem, it says, list all the zeros we did. It says, find the rest of the zeros. Well, guess what? Here they are. Negative 3, right? Negative 1, negative 2, negative 3. Got it. 5/3. 5/3 is 1 and a bit more. That's good enough. And 5. Oops, I'm sorry. I need to scale the whole thing. So more than 1. This is 1, this is 2, this is 1 and 2/3. And 5. 1, 2, 3, 4, 5. This is a cubic. We know how a cubic look like. The y-intercept is 75. There's 75. We mark that. And do you notice that the multiplicity is a 1 on each of those? So, like a straight line. Like a straight line. And like a straight. Right there, like a straight line. And like a straight line. And that's more than enough. I'd like to look at number 32. And the constant term is 45. The factors of 45, 1 times 45. 2 doesn't work. 3 and what? 3 and 15. That's 45. 4 doesn't work. 5 and 9. And that's about it. 6 doesn't work. 7 doesn't work. 8 and 9 and 8. There it is. And the leading term is actually a 5. The factors of 5 are 1 and 5. So the possible zeros would be all of this divided by 1, 1, 3, 5, 9, 15, and 45. And let me list that underneath so they fit. And if I take all of these divided by 5, 1 divided by 5 is 1/5. 3 divided by 5 is 3/5. But 5 divided by 5 is 1, it's already there. 9 divided by 5. 15 divided by 5 is 3. And 45 divided by 5 is 9. So those plus or minus. Now what? I'm going to check, does 1 work? If I throw a 1 in, well, what's f of 1? That is 5 plus 7 minus 81 plus 45. For sure, that's not going to equal 0. 1 and negative 1 are not going to work. What's the next number? Let's try 3. I'd rather use syntactic division than, unless I have a calculator. So 5. 3 times 5 is 15. That's 22. This is where you want to work slowly, because if you miss a 0, it's going to be very hard to make it up later. That's 66. And 6 out of 11 is a 5. And 6 out of 7 is a 1. Negative. Multiply negative 45. Like I said, 85% you're done right there. That leaves me with 5x squared plus 22x minus 15. Which means 5x and an x. And let me see. 5 and 1. 5 and 3, 3 and 5. You want them to subtract to get you 22. 25 minus 3 is 22, right? So that is a 3 and that is a 5, and you want a positive and a negative. So 5x squared plus 25, there you go, times x minus 3. Well, hey, again, it happened that the multiplicities are 0 on all of those. We know how to graph f of x equaling x minus 3 into 5x minus 3 into x plus 5. All of these have multiplicity 1. That's an easy graph. So once you factor it, it's easy. 3, 1, 2, 3. 3/5 and negative 5. The y-intercept is 45. Cubic. Since it's multiplicity 1, you go straight across, and you're going to come straight across and straight across. And there it is. And that's pretty much what it is. The last few problems, it says find all the zeros. We want to do a bit more.